So question 1b is the equation of a plane. So to find the equation of a plane containing 3 points, show the plane does not pass through 3, 2, 1. The formula for the plane is relatively straightforward. It's the normal vector n times or minus or 0. Or 0 is any point in the plane, or is just the variable x, y, z. Because think, a plane, like a line, should have variables. And because it's 3 dimensions, it should have 3 variables. The line has x and y, the plane has x, y, and z. So, for this question, you need to get the normal vector. But to get the normal vector, you need 2 vectors. So we start with 3 points. 1, 2, 3. And we subtract them from each other to get the vectors u and v. Yeah. Now, as a method, it's just always best to just be consistent. It doesn't matter which one you choose to subtract, but always being the same. And I'd also recommend that you choose the one that makes the least impact, the easiest one to subtract. 0, 1, 0 means you're only subtracting the middle term. So, or 0 minus or 2, 3 minus 1, 0, 0, 1, 0 gives me 3 minus 2, 0. Minus 1, 0, 2, minus 0, 1, 0 gives me minus 1, minus 1, 2. Yeah? So now we have to calculate the normal vector, which is the cross product. N is equal to u cross v. So here's our new vector u, and here's our new vector v, and we do a cross product of them. Like before, you cover this up, so minus 2 times 2, 0 times, so it's minus 4i. Cover up the middle one, so it's 3 times 2, 0 times, but there's a minus in front always, so it's 6 minus 6j. And then lastly, we get 3 minus 1, minus 1 times minus 2, so that's minus 3 minus 2 gives us minus 5. So that's our normal vector. Now, the definition of the plane is n, which is our normal vector, times or minus or naught. Yeah? We just calculate our n. So now we input it. So that's our n. This is always the same. And here is our or naught, the one we used each time to subtract. You could input any of the 3 points, but it's good just for yourselves to be consistent with it. And the most important thing is this has to equal 0. Yeah. So then we do the dot product, minus 4 times x, minus 6 times y minus 1, and minus 5 times z. That's all equals 0. So this gives us, that's minus 4 times x, that's minus 4x. Minus 6 times y gives me minus 6y. Minus 6 times 1 gives me plus 6. Minus 5 times z gives me minus 5z. That's all equal to 0. And we can rearrange it such that we have minus 4x minus 6y minus 5 equals minus 6. We could even multiply this all by minus 1 to give us 4x plus 6y plus 5z is equal to 6. Now, to test if the point 3, 2, 1 is on the plane, just input it into the form of the line of the plane. That should say plane, and that should say plane. Minus 4, 3 times 3, minus 6. Now this all equals to minus 29, which does not equal minus 6. Therefore, it is not on the plane. Variations of this question actually could be much easier. That I give you 2 points, 2 vectors and a point. Or I could even give you a normal vector and a point, and then you wouldn't have to calculate the normal vector. So, the last question, last part of question 1, calculate the tangent vector of the vector path. A vector path represents how something moves through space. So here we have x, y, and z are all a function of time. Yeah. So we have some path 3, 4t, 3t, et, cos pi t. And we're interested in what's the tangent vector at t is equal to 0. That gives you the rate of change, the velocity of that particle or movement at that point. So really what I'm saying is ft is equal to x to the function of t, y to the function of t, z to the function of t. Then the tangent to the path is calculated by differentiating with respect to t. So the vector, each component gets differentiated xt with respect to t, yt with respect to t, and zt with respect to t. And then to find out what the specific tangent at the specific point is, you fill in the value of t is equal to a. So here we have our path ft, or fxt, yt, zt is equal to 3e to the 4t, 3t et, and cos pi t. So what we do is we break it down to 3 parts. First, differentiating the x part. So that's differentiate 3e to the 4t. So the derivative of that is 3 times 4e to the 4t, because the 4 comes down. Yeah, 12e to the 4t. Next one we deal with is the y part. Now, this is the product rule, so be careful here. 3t e to the t. So the first part is I differentiate just the t and keep everything else the same. Derivative of t is 1, so that's 3e to the t plus 3t e to the t, because I'm differentiating the e to the t part. Derivative of e to the t is just e to the t, so that maintains. Yeah. The last is derivative of cos pi t. Derivative of cos pi, pi comes to the front, and you differentiate thing. This is a chain rule. Yeah. Minus pi sine pi t. The tangent of a path at that specific time point, you let t is equal to 0, so you put it in f dash 0. So you have 12 e to the 4 0, 3e to the 0 plus 3 0 times e to the 0 minus pi sine 0. And so the answer is 12, 3, 0. So that's all of question 1.